Okay, let's get started. Today we're going to finish Lecture 4, which was covering gaining competitive advantages using IT. And we'll finish 4 and start on 5. Just to recap, because it has been a whole week since last time you were here. We looked at supply chain management already. We're actually going to look at, in Lecture 5, we hit it in a lot more detail. This is basically just an overview that I'm giving you at this point in terms of how IT works with information systems and supply chain management, and how the IT component of it is structuring the way that's transforming and being done currently. We started talking, I think, a little bit about customer relationship management, maybe e-collaboration. I think I'm going to start with e-collaboration, which is, I think, maybe where I left off. Does anyone remember? I don't know. I think it was like slide 20-something.
27.
Oh, 27. Oh, good. Thank you. Thank you. So we talked about CRM. Talked about e-collaboration a little bit, integrating virtual teams, workflow management, knowledge-based systems, social networking. If you remember, we talked a little bit about how advertisers are...
Slide 26.
Slide 26, okay, good. E-learning tools, slide 26. This is about where we stopped. Yeah, okay, good. So this is where we'll pick up. Informal collaboration. So what we've been looking at in terms of the e-collaboration, and I might have to go back here a little bit to look at the organizational focus that it has brought to the business community. When we talk about informal collaboration, we're not really looking at organizational focus. Instead, we're looking at communication and using e-commerce, electronic forms of communication to basically create collaboration with remote teams, with remote business partners, with ideas that can be generated from all different sources. So informal collaboration tools focus on the informal groups of people and getting them together, either asynchronously or synchronous in fashion. So meaning that they're all visit at the same place at the same time, or they're coming and going at different times in different places. Which brings up a couple concepts. One of them in general is the wiki concept. And so the wiki concept is being used a lot in businesses, actually, for frequently asked questions, for how-tos, for customer support. So if you can kind of use like an informal collaboration with some formal collaboration tools, such as a website, maybe some forum, some way of customers or suppliers coming together to essentially deliver information when needed and for people to gather information, which is kind of the wiki concept. So it allows visitors to create, edit, change, put up ideas, add content, and eliminate content, do all sorts of different things collaboratively, which you can do in a business to basically streamline a lot of these different processes. So such content is also called open source information. So some of you might be familiar with open source software. That's kind of like free information. Instead of buying a textbook, what you're doing is you're going to a wiki. One problem is, especially with the internet, the concept has failed. So you don't, as a general rule, want to use Wikipedia for anything. It's not legitimate information. In fact, most of it's written by people who have no idea what they're talking about. And so it's a great attempt to create an informal collaboration platform. However, it relies on the people. And so if the people, who are not degreed in something, who don't even study anything, start acting like experts, go online, start posting a bunch of stuff as if it were true, then we have a lot of bad information. So open source information is not quite the same quality as published information, or copyrighted information, I should say, that's supposed to be legitimate. So the content is publicly available, free of charge, and most often updatable by anyone. Well, there's your problem right there. And there's nobody that checks it. There's no content expert that goes into Wikipedia and says, this is correct, this is not correct, or actually makes any attempt to validate anything. So actually, a couple of years back, I knew of an 11-year-old. There was a story in the Mercury News, actually, the local paper. It was an 11-year-old kid who started posting medical information. And 11-year-olds, they haven't been to medical school yet, theoretically, unless they're like what was that old movie with Doogie Howser in it? So, the kid has no medical background. He's 11 years old, but he's posting remedies and things, for people to do in certain cases on a medical website. And it just goes to show you, people were actually reading that and taking it like a doctor's advice when it really wasn't. So, and, then the article was mostly on what liability, do the parents have for not monitoring the kid who's doing this? Because if he were over the age of 18, it would be his responsibility, but he's not. And then is it right or wrong? It brings up a lot of ethical, kind of moral questions as well. There's nothing wrong with it. If it's an open forum, if you think about it, if it's a wiki, you don't know anything about construction, but you want to play around and you write something about construction or something about medical or something, somebody reads it, takes it for like the truth. That's, is it, whose fault is it, kind of thing. So now, actually, the government is thinking about, the U.S. government is thinking about providing some more monitoring of that, some requirements, some regulations to say that if you're publishing this information out there on the internet for people to read, it has to be true. So, but that kind of violates freedom of speech as well, though, too. So, I don't know. There's a lot of issues associated with that. We haven't quite figured it out, and I'm really not quite sure we're going to, actually. So if you want to take that and use it as a business opportunity, obviously the same kind of problems is basically going to comply with that. I mean, because you're going to have customers who are posting solutions to problems on a wiki that, are supposed to help other customers maybe, but they're wrong. The solutions are wrong, or, something's wrong with the advice. So opportunities for e-collaboration that make sense, good for just about every type of business strategy and when monitored correctly. So the key thing to take home is the implementation, the monitoring of it, the focus. So hopefully the focus for differentiation, for overall cost leadership, and top line, bottom line, also to run, grow, and transform. It works with all of those different types. Hello. So, and here's a little chart that shows the IT support for e-collaboration. So just a few of the literally hundreds of e-collaboration tools that are available, and that's readable. So as kind of a, if you look over into the third column under the examples, and these are clickable links actually, like Live Meeting is a great e-collaboration tool. Metastorm, FileNet, Groove, LinkedIn. LinkedIn is still as a social. It's really a business social. If you're not on LinkedIn, it's probably something you probably want to do because it's a great way to get job leads and make social business friends and stuff like that. And then we have this concept called the IT culture. So the culture refers to how the IT function is placed structurally within the organization. And some organizations don't even have an IT department. Some organizations outsource everything. Some have a strong culture. Some have a weak culture. So the word is actually kind of generic in a lot of ways. It's just referring to how the structure is working, the organizational philosophy, their approach to the development, the deployment, and the use of IT. So some companies, let's say for example eBay, PayPal, they're high tech. I mean, they have a high IT culture, strong culture. Some other companies, like let's say, I don't know, a Noah's Bagels or something, or a bagel shop at Delhi, they're probably gonna have a low level of, or maybe no culture at all. So you can define the culture and actually create it. Promote an IT culture, which might give your company a better strategic advantage in terms of the use of the IT, especially if you get everybody on board, you make everybody IT savvy, everybody, because if you can hand out tools, it's like, what is that concept? Lead a horse to water, but you can't make them drink. So you can hand out tools and you can provide applications and programs for your employees, but you can't make them use it, and they're only going to use it if they see a value in it. And so if you create the IT culture using a high level of technology perhaps, then you're actually kind of getting them all involved in a group and you're making them all conform to the goals of the company per se. So we have a top-down silo here where we've got an IT function handles all of the IT needs. We have what's called a strong command and control structure where we have, let's say as an example, all of the IT command and control is focusing here with the CIO, CTO, CSO, CPO in terms of the function. Instead of just having one CIO, Chief Information Officer, so technology officer, we have all sorts of different forms of providing the infrastructure for it. And then we have kind of the matrix kind of look here. So in this first pattern, what we're looking at, and this actually plays a huge role, significant role, in the strategic advantage of IT used in the company, because it depends on how you're defining your structure, how you're creating your culture, is going to influence how well people are going to adapt to the technology, how well they're going to be, how well it's going to be accessible to them, and how much of it that they're going to actually take advantage of. Because you want them to use the technology, you don't want them to run away from it. And a lot of managers, especially who aren't IT related or IS related, no technology background, they're business people, they may not necessarily like technology. They might actually be afraid of it. So it depends on how you're going to place it into the structure. So here's the IT functional structural placement with a matrix. Instead of a top-down hierarchical view, we're looking at a matrix where we've got a function for IT that runs throughout and crosses over with the marketing and the finance and the sales. And this is not all the this graph is not showing you all of the different departments. It's just a sampling. So we have a separate IT department, but the decisions are making in a matrix kind of cross the organization kind of function. Here what we have are the decisions being made as IT functions from the IT line. And so they're making all the decisions for everybody else. They're not really involving everybody else. This creates a culture in which you have collaboration among all of the different departments, hopefully integrated in with the IT department. So as an example, let's say you're in the marketing department and you're running a marketing function, and you're over here. You're going to go to IT. You're going to request the service from the IT department as a culture of the company. Say, hey, we want to automate. We want to do stuff on the internet or something. We want to automate our sales campaign or a marketing campaign. In this example, we'd actually have an IT person in the marketing department who would be sitting there going, instead of them coming to us to ask for us to help them implement something using IT, we're already in the department. We're looking at this going, you guys should use internet, or you guys should use this, or making the suggestion and actually playing a role in the marketing function, providing the IT support. So you've basically spread out the IT culture a bit. Instead of centralizing it, you're decentralizing the people, and you're making them more responsible for other department needs, which makes them more accessible and gives you more collaboration among the different departments. Because what you don't want is a company where you've got IT department in the corner. They don't interface with anyone. They don't collaborate with anybody. Unless someone comes and asks them something, they're not going to get any help from them. Or they're not, maybe they'll get their computer fixed, but they're not going to get strategic anything done for programs, for implementations of things. And now we have a fully integrated, which is pretty much the goal of today's IT, is to fully integrate it. So here we still have an IT department, we still have IT functions, but we're trying to get collaboration by putting one or two people out there to kind of bring in the rest of the groups. Here what we're doing is just taking and making a marketing IT function, a finance IT function, and separating out, and we're reducing the IT department by its own. Instead of sitting on an island on its own, we're taking some of those people and we're physically moving them out. And we're making them part of the other departments, rather than a liaison between the departments, which is where you the fully integrated kind of approach. So you have a separate IT function, but it's IT personnel that are placed with functional areas. So it's a tremendous empowerment for them because they're dedicated to marketing, they're dedicated to sales. And everybody's working, hopefully, for the goal of the entire company, but they can specialize. So we have a tremendous empowerment across all of the functions when we take a look and we make it part of the departments. So that actually changes the culture of the company, if you think about it. Because, most companies that run with a department type of structure, they have traditional layouts. If it's not a marketing thing, then it's a sales thing. If it's not a sales thing, it's an accounting thing. And everything gets separated out by departments, and sometimes the cultures are different, the work environment's different among the different groups. When you do this, you kind of merge it back together a little bit. You cross-function. So you have IT people that are cross-functional in marketing and accounting. You're wondering, well, why do we need an IT person in the accounting department? Because someone's got to support your IT needs. Someone's going to think about how you're implementing IS&T to essentially make your department grow and be more effective. So they might not be doing accounting work, They're going to be doing IT work, hopefully. So we have this philosophical approach to the IT culture. It ranges from a variety of different levels, from the bottom, from the non-significant, just kind of like, let's just wait and see kind of approach. You have to prove a return on investment before adopting the technology. It's kind of like, you know, when cell phones came out. Well, let's just wait and see if everyone's going to get a cell phone. Or iPads. Let's go wait and see. See if the iPads are popular kind of philosophy. A lot of companies do that. They let other companies try stuff out. Oh, they're doing electronic shipping. Well, let's just wait and see how the companies are doing it and how effective that is for them. Then maybe we'll adopt it or something. So, or we have what's called the early adopters. These are the people that, you know, wait in line at the store to buy an iPhone when it first came out. The companies that essentially run out and buy before it's even ready, before it's even tested. They're already implementing this new technology because they want to do, you know, they want a competitive advantage, or they're eager and they're anticipating that it's going to be good. So it supports a technology innovative failure. So a reward system for trying new technologies, even if they're proven, even if they prove to be unsuccessful, they tried it. So these are the people, the early adopters are the people that went out and bought iPads for all of their salespeople and then realized they didn't need them. Or they didn't support the applications that they needed. They couldn't use them to remotely log into their servers. They were too expensive, or there was a problem with them. But they're also taking the chance that it might actually give them something of value. So there's pros and cons to it that need to be weighed. And here's kind of the centralized versus the decentralized approach. And what we have is wait and see adapters versus early adopters. On the horizontal and the vertical axis is the decentralized versus centralized. And this would be essentially the approach to the way the company is structured, the organization, versus whether or not they're wait and see or whether or not they're early adopters. And to give you an example here, the more centralized, the bigger companies are more centralized than decentralized ones. But that's a myth of the past, though. If you take as an example, because some of you probably aren't familiar with the way this terminology is being used in this chart, a centralized company would be like an IBM that has one headquarters and one marketing department, one sales department. And they have everything centrally located, usually. It doesn't have to be centrally located. But they're using one marketing, one sales, and it's all pretty much housed under the same roof somehow. Decentralized would be like an HP company, where they have product group A, product group B, product group C. And A, B, and C, they all have their own sales department, marketing departments. Sales, everything is separated out. So in that kind of a company, they're more flexible. They run at a higher cost because they're duplicating efforts across product lines, but they can be very innovative. They can easily add something and take something away without ruining everybody else. Like if the home electronics product group wanted to add iPads, they could do that without affecting the scanner groups or the monitor groups or some of the other product lines. So the technology, they're up here, they're early adopters. They're very early adopters, and because they're flexible. And they can take technology innovation failures quite easily because they're not buying it for everyone in the organization. They're buying it for the decentralized component by component. Over here, we have a huge risk of disaster. So we're going to be late adopters. We're going to wait and see, and we're going to wait until it's proven before we do it. Because to upgrade the network in a centralized environment, it's bigger. The network's bigger. The centralized, we're going to affect everybody. And if we make a mistake, there's more of a risk. So sometimes it's more of a weighing of a risk factor. Sometimes it also might be how fast you can implement it. So you can spend on a centralized kind of environment, you could spend months, years implementing something, and by the time you had it implemented, there would be a new version of it out. You know, and if you're doing something that's unproven, you don't want to have like this new version that's outdated by the time it's actually even implemented. So, standardized software that's proven is more along the lines of a centralized And you can actually call it wait and see. You can say early and late adopters. So we have late people and we have early people. In fact, that's the whole psychology of consumer products, selling to consumers. We have early, middle, and late adopters, where we've got different categories of the kinds of consumers that'll go out and buy something. So let's talk about enterprise resource planning. The word that always confuses everybody. We have more of this in the next lecture as well. This is just the overview at this point. So how do you bring together supply chain management, customer relationship management, e-collaboration systems with an ERP system? Well, you actually have to reorganize the entire company. So going back to this kind of concept, you pick whatever you are, it doesn't really matter. You have a starting point. You take and you totally transform all of the work tasks to meet the needs of the ERP system, restructure the work, build the system. A lot of effort, huge implementations, a lot of work. And there's a lot of failure in the concept because people either fail to restructure, fail to actually design the company structure to meet the needs of the ERP and vice versa. So that's what the slide says. To collect in terms of what we have by definition, enterprise resource planning systems, they're supposed to be a collection of integrated software for business management, accounting, finance, supply chain, inventory. Well, it doesn't really tell you anything, actually. And that this type of system is the most frequently misunderstood. What it's supposed to be doing, however, it's not a network. It's more of a middleware / tool that's used, and the ERP brings things together. So what we're doing is we're taking finance, human resource, sales, marketing, operations, logistics, integrating everything together and making it part of a bigger system. And this is where we get this concept of the enterprise. So we have enterprise organizations that can use enterprise resource planning because they have a relationship with their suppliers, with their manufacturing, with their customer relations. And they're using something, a tool, an ERP tool, maybe not labeled ERP, it's probably called enterprise something, where they're creating the electronic collaboration between all of these different departments. And that's really what ERP is actually kind of focused at, enterprise resource planning, is creating an enterprise through technology. So if you can kind of just keep that in mind as the general definition, then the rest of it's actually a piece of cake, because you just take each one of the subcomponents of it, and it's the same as if it weren't a component of it. It's a separate, like sales and marketing functions, systems, they're all the same, whether they're part of an ERP or not. So if they're part of an ERP, they need to be transformed so that they can interface with the ERP. So what ends up happening in most of the implementations is we get ERP systems that aren't integrated well. That although we have all these pieces and they're supposed to be working together, it doesn't function well because the way that something is going on in sales or marketing is counterproductive or counterintuitive to something else that might be going on. The information is not translating correctly, or people just don't know how to use the information. Here's some examples of major ERP vendors. This school's pretty hip on SAP, so you guys are probably taking SAP classes, or you're probably familiar with that concept. The target market for that is going to be a large business. The type of specialties, if you're not familiar with the concept, customer relationship, CRM, financial management, human resource management, supply chain management. SAP in general, it kind of overlaps in a lot of those different sub-areas. Not a bad thing to know about, because as people start implementing these ERP systems, SAP skills are important because, if the system, if you're out there helping create the ERP environment, and there's very few people from a traditional kind of business school background that actually have those skill sets. So that's why we offer that certificate when we have all the SAP courses. Oracle and PeopleSoft, maybe not actually as popular these days, but still around. Because if you're going to buy a PeopleSoft system, it's extremely expensive. The problem with PeopleSoft is it's harder to understand than SAP. And again, there are fewer people who are trained in it. And really, it's just in a large business environment again. So you have to look at, if you're going to implement something like that, then what you're going to do is essentially send people to training or hire PeopleSoft consultants, like you hire SAP consultants, and then what ends up happening is, you spend a lot of money supporting the system because not everybody can work on it because they need a certain skill set in order to understand it, in order to interface with it. And for financial management, human resources, supply chain management, not very much customer relationship management, not so much ERP use, but it does have a share of the market. SSA, Global Bean, same kind of concept. Microsoft, Great Plains, excuse me. Small, medium size. So what we're looking at is just a couple of different major vendors in the market. Not to say that anything new has come out, but I really don't think so. We're looking at 1, 2, 3, 4, well, okay, 3.5-ish, possibly 3. If I were to say, we'd probably have more SAP than anything else out there. PeopleSoft would come next. But PeopleSoft is just so difficult to work with. So let's talk about some of the goals, some of the incentives of ERP. So it attempts to integrate everything. So as I mentioned before, creating an enterprise is all about integrating all the cross functions, putting your suppliers, putting your manufacturing, putting everything together, your supply chain and everything together. And customer relationship management drives what supply chain management will produce, if you think about it, in terms of how you're putting it together. Everyone works together in e-collaboration, hopefully. And the entire organization knows the entire organization, hopefully. So if you think about school in general, can you register for a class with a bill outstanding? Hopefully not. Although, if you're not using a type of system that's going to integrate all of the functions, it's quite possible to actually register for a class while owing tuition money or something. Or register for a class for which you're not a major of, like it doesn't apply towards your major or something, which might be an issue, I think. Can you register for a class for which you haven't completed the prerequisites for? Probably. Actually, there's no check on that. So what you use the tool for in a business is to make sure that every customer who is purchasing something has something else automatically. And you're essentially automating a lot of the integration of the information from the different departments is what you're doing. So you're making sales information available to marketing people. When a salesperson puts an order in for, let's say it's a car dealership who uses an ERP system, they order, you want a blue Toyota. It automatically integrates with manufacturing, supply chain stuff to say, we have one more. It's already scheduled on the production line to be built. It's already, parts and things are already ordered for it. And then the system can come back and say, well, your estimated delivery time is this date. And you're like, oh. Because the system already has it. Once you entered in once, it's already entered in everything else. It's already planned for, essentially. But you don't get it in the old days. In the old days, people say, oh, put the order in. And it's not just manual entry. It's not just data processing that this is eliminating. It's communication. It's the physical communication between the people. Because nobody from sales has to tell the marketing people or the production people or the manufacturing site that's located in China or something that somebody ordered this part, somebody ordered this product. It's automatically streamlined through the system. All interested parties can have that information instantly as soon as the sale is actually recorded. So here's kind of another picture of what I just mentioned. So we've got customers on one side, suppliers on the other side, human resources down here, sales, service. There's a bunch of departments going into the ERP system. So there's no left hand talking to the right hand. The technology puts it together. You can't run a big, you can run a big business without this, actually. It's very easy to. And if you put this in, you got to transform what everybody's doing so it meets the needs of the system. As an example, the salesperson who needs to properly enter in the information into the ERP system through whatever channels that they're available to, through whatever applications they're working with, so that the manufacturing people over there in China have the information that they need to produce the product to send it back. He doesn't have to get on the phone and call those guys and say, hey, somebody else ordered one of these. It automatically gets integrated in. So the automation is really the strategic advantage that this type of system is working with. And it's not just for manufacturing. People use this for customer relationship management. They use it for a lot of other, to integrate, let's say, for example, recalls. You have, the entire United States. You got 50 some odd states of people who are bringing their cars into car dealerships, if you're spread out as a company, and they're all having minor little problems, like maybe it's a steering wheel or something like that keeps breaking. Then you might be able to capture through an ERP system all of the different service locations have reported all of the different problems, put them all together to see what's happening, what's the big picture, and then oh, we need to change that part because the plastic weight that we're using is too light. It breaks. We need to use a heavier weight plastic in the manufacturing. So it doesn't take a year or 2 years. It takes a month. It takes a week. So some of the goals of the ERP system is to speed up the process of troubleshooting problems, speed up the communication, and then provide the automatic communication, which cuts down on the workload. So if you have a nice ERP system, not only do you have the e-collaboration, but hopefully you're running streamline. You don't have a billion people working for you doing all the stuff manually. The system is doing it for you. So that's kind of the introduction to ERP and supply chain. And what I want to do now is look at Lecture 5. And no, we're not going to go through everything we just went through before. What this lecture does is in the beginning, reviews, and I'll just quickly go through it, and then I'll hit the new stuff. Because what I want to do is kind of give you some more specifics on how to apply the strategic advantage of these particular technologies. So this is Lecture 5, and it's kind of mislabeled. It shouldn't be Information Technology Supply Chain Management, more than just supply chain. It just starts out with that. So if you missed last week, we know we already talked about supply chain management. And that was the process of managing the components in the extended value chain from suppliers through manufacturing, through distribution, to the customer. So everything from, if you're building the product, everything from acquisition of the pieces, the parts, to the assembly, through the delivery is your supply chain, essentially, in terms of what you're looking at for the IT automation. It may not necessarily be part of what you're calling supply chain. It might just be separate components that are connected to it. As an example, your inventory system may not necessarily be part of your supply chain. In fact, when we start looking at ERP systems, we start crossing the lines, and now, maybe inventory is part of supply chain. And maybe, we start putting things together in more of a collaborative fashion, so we have less separation between what belongs in which system. And we have one big system, hopefully. So here's an example here. So why? We already know what it is, hopefully. If we don't know what it is, let me know. I can tell you what it is, but I think we pretty much know what it is. Why do we want to use it for an information systems, information technology strategic advantage? We want this automation, and here's an example here for parts, labor, overhead, management costs. Total cost $14,000 for a car. Now, 50 years ago, U.S. is the only country that can manufacture cars. You buy a car from GM, all the money goes to GM. So now in let's say the year 2000-ish, we start looking at, and actually it's about 10 years old, I guess. So traditionally, manufacturing of automobiles didn't use supply chain management kind of systems. Now we have foreign parts and labors are much cheaper than the U.S. market, of course. So we buy a car from GM, only a portion of the money actually goes to GM. Because what we can do in this particular scenario, and this is what happens actually, just because you buy a car that's built in the U.S. doesn't mean it actually has U.S. parts in it. Same thing, you buy a car that was built in Germany, doesn't have German parts in it. In fact, most of the cars here are built elsewhere. We don't do any manufacturing anymore here. Actually, Numi used to do manufacturing for a while, but they imported all the parts anyway, so it's as if it was built elsewhere. But long story short, what we're looking at is this dollar amount down here and who it's going to. So we can create an enterprise to build cars, essentially. All under the same roof. It's all built under the same product. The customer's only buying one product, essentially. You're buying a car. But with the car is sold to you by half a dozen other people. So you bought it from Volkswagen or whatever. You bought it from, it's a GM, it's a Toyota, it's a whatever manufacturer. They're not really the manufacturers of it. It's actually kind of like subcontracted out. The engine's coming from somewhere. The body pieces are coming from somewhere. So we can take a big, expensive, time-consuming process and make it shorter and make it cheaper and spread the wealth. So the kind of concept of who owns the car. I mean, when you're buying it from the person you're buying it from, they don't necessarily own what it is they're selling you. It's accumulation of a bunch of different pieces, and if you have a supply chain management system set up, you can strategically build all sorts of products, not just cars this way. So you have components that are being sold by other people that are part of the product you're selling that are managed by those other people. And you're just collaborating everything together like an enterprise, and you're providing the means for the sale and the complementary product components, if that makes any sense. So the value chain analysis here, if we break it all down, this is really hard to see it, so it's kind of similar to what we saw last time. When we have the firm, we have suppliers, the firm, distributors, and so what we're doing is we're taking the primary activities and the support activity, and we're taking the primary activities and we're separating it out, essentially what we're doing. So we can put it all back together in the end product. Sometimes, actually, when you buy software, actually I think I've shown you this already. When you buy software, sometimes components, you have drivers, that's actually kind of going through a supply chain as well, but we don't have to put a supply chain management system for this. And in terms of software development, if we have drivers, we have interfaces, library packages, tools, support, stuff like that. Same concept. We don't own that stuff, but we built an interface to it. And when we give it to you, we're packaging it up all together. A little bit of that is going to the runtime engine people. A little bit of it is going, a little bit of that revenue is supposed to be going to the people who make the drivers. A little bit of that revenue is supposed to be going here. What ends up with a software company is that, they just steal everything. They sell it like it's theirs. Can't do that in other companies. You can't do that in other industries because you can't get away with it. But software companies, it's easier to kind of break the enterprise concept, per se. Include open source that's supposed to be open source, but you're selling it, so you're violating open source rules. So, I have actually given you this already, right? Have I given you this? I think this... Does this slide look familiar? Maybe a couple weeks ago? No? Somebody answer. One token person. Are you guys awake? Have you seen this slide yet? Yes. Okay, good. Thank you. All right, service. No, I think I covered it like a couple weeks ago. Yeah, okay, good. Very good. Okay. Service. The concept of supply chain management also applies to service. So the example I gave you a few minutes ago was for manufacturing, cars, stuff like that. All right, so service, so business process management, business process re-engineering in terms of providing service. What we can do is essentially take and look at, I've covered this actually already, and the service essentially is in the, not only the manufacturing, however, but in the delivery of the product, the delivery of a service, where we have, where we see service is more along the lines of building houses. So the contractor that's building the house doesn't know anything about electricity, doesn't know anything about plumbing. He's the general contractor. He hires out, subcontracts out to provide services for the electrical, the water, the roof, the construction. And they're coming in and they're doing something, providing the service either through a project in which they're constructing something, or they're doing, if it were like a software company, they might be doing troubleshooting. So a company like Gateway, as an example, can sell service contracts that are outsourced, but not really outsourced. They're actually other suppliers that are selling the same, they're selling something along with your computer. So when you call in, you're getting, an outsourced company, another supplier is providing you the service to repair a problem that you have or something of that nature. But they're supporting the Gateway, or they're supporting the Dell, or they're supporting whatever computer that you bought, but no association with the company, which is interesting. You get this a lot with long-term contracts for, in fact, you can get it in a non-tech environment. You can get it from anything from like cleaning, janitorial services, through construction, through software development, through almost anything. You hire a service company to come in to make your user interface design. And they're selling the user interface design with every one of your products. Or it's a service to do your MP3 encoding or something. And they own the algorithm, and they're shipping it with your product because it works with your product. But they're providing that feature, that service that goes along with it. In terms of business process re-engineering, in order to provide a service through supply chain management, you got to re-engineer, because you're taking away that business process and then you're providing a way of interfacing to another entity or another supplier. So from the article published in Harvard Review, in fact, it's referenced at the end of the slide set, actually. It doesn't, there's a reference for that at the end. You can do some radical business re-design that initiates, that attempts to achieve dramatic improvements of business processes by questioning the assumptions or the business rules of the company. Kind of a generic definition of what business process re-engineering is all about. I like to say, fire everybody, hire new people, and have them do different jobs. That's restructuring / business process re-engineering, where you're taking and you are revamping everything. It's like, you know, everyone stop what you're doing, and now you have a different job. This is what your job is. And just restructuring all of the work to make more sense. Because what ends up happening, especially with a lot of small companies that get big, the work tasks, the business processes that are being performed get skewed. Some people end up with a lot of work, some people have a little bit of work, and then you start adding on more people, and they're doing all of the new stuff that you need to have done, but the old stuff is still over here. And so it's not structured correctly than if you just dropped everything and built it again from scratch, which is what a lot of companies do, actually. They have this thing called continual process improvement, where you're supposed to not do major transitions, which is what business process re-engineering is major. This is the, you walk in Monday morning, everybody's laid off, and then Tuesday everybody's hired again, but you all have different jobs. That's because they re-engineered everything. Continuous process improvement kind of goes by monthly, by annually or something, and it constantly evaluates what each person is doing and makes smaller changes incrementally throughout the year without the big drastic reduction of staff, the drastic layoffs. So, information technology for supply chain management. Okay, so we have software systems and network systems. Most of you are probably familiar more along the lines of the middleware, actually, the SAP, the PeopleSoft, those types of tool sets. But in terms of information technology and taking advantage of what's available from a strategic perspective, we're looking at, you probably could just see it from the slide, I mean, a lot more than just the middleware. What we're looking at is taking and utilizing electronic data exchange as an example, integrating EDI in, totally different concept than SAP or PeopleSoft. It's the concept of the tool that's being implemented, materials requirements planning, manufacturing resource planning. I'm not going to go through all of these, it would bore you silly. We've already talked about enterprise resource planning in terms of, that's only one form of supply chain management technology. It can be used for customer relationship technology as well. Internet-based software, and then we have networks. We all know about that, and the internet in terms of the network infrastructure. So if we're going to take and look at planning systems, so this is not, again, this is not a repeat of it, because sometimes I have students look at this and go, enterprise resource planning, we just covered that. No. Looking at the planning component this time around. So if we're looking at it in terms, what we're really referring to is linking together individual applications and planning how the operations are working together. So for example, accounting and manufacturing applications should be integrated in terms of the enterprise to create the enterprise into a single application. It integrates data and business processes of the entire business units of those two. But it's more than just the two. So if you take ERP and apply it to just, in this particular case, accounting and manufacturing, you're not really solving the problem, or you're not really creating anything new. You've improved the communication between the two. So here's what ends up happening. People take and they buy these expensive ERP systems and they put them in and they merge two departments. And then they go, well, it's not really bringing us anything. We have the system, we're using the system, but we're not really seeing a benefit from it, and nobody knows how to use it. So you actually have to take a significant portion of the organization and put it into the ERP system and integrate it. Otherwise, you're not going to see anything. There's no sense in buying the software. It's like, you know, if you have a wired network and you got wireless, you know, it's like, okay, you know, you already have that. You're just using another form of wireless instead of wired. You already have a network. So this is like what a lot of companies do. So Here we have the ERP system in the middle. You can hardly see it. But we're taking and we're cross-functional with more than 2 departments. And we're actually taking the business processes, the planning, the projecting, the strategic analysis, and we're putting that into the system as well. So the point I'm trying to drive home is everything is part of the system, which takes a lot of business process reengineering, if you think about it. You can't just drop everything and put it all into the same system again, because what ends up happening is people have their own systems, and they're stuck in this mindset of, oh, this system does a good job, it's not broken, don't fix it. But what they don't understand is just because that accounting system works, you have to use this one over here. And because this one over here integrates with everything else, although you like this one over here, we're getting rid of it. And what a lot of companies actually try to do, and what happened originally, is we had middleware that put it all together. So they liked the accounting system over here, and they just, okay, we'll just move it over here. So then there's a lot of data transfer, a lot of backups, a lot of batch jobs, a lot of manual transformation between this system over here and this system just to put it together. Yeah, we can make it work together, but you have to print out reports every day and put it in manually. Or the computer at nighttime takes 2 hours to transfer all the data from this system to that system. And it's very time consuming. So the origin of it, and the origin of it kind of tells us what it was primarily in the beginning useful for. And it kind of grew out of that, actually. It's used for a lot more than that today. And they grew out of functions called materials requirements planning, used for allocation of resources for manufacturing operations. Because if you think about manufacturing, could really utilize ERP to the fullest. Now they're used for more than that. Systems ultimately became very complex, allowing for efficiencies of scale not previous possible, in the past. Because if you think about the components of building a computer, as an example, and how many different components are involved with the assembly of that computer, or a car, or an iPod, you're looking at a lot of subcomponents. A lot of subcomponents are going to be put in with other subcomponents. A lot of pieces, a lot of parts, a lot of assembly work to it. It's really hard to manually schedule that, manually plan out. So you use the ERP system, puts it all together, makes it possible with very little human effort. By the 90s, other enterprise activities were incorporated into the system. So it took until about the 90s, I guess. So really, they've only been around since the 2000s in full operation. And they're still not very popular. And the people that have these systems don't know how to use them, which is interesting, which is why there's such a need for consultants to go out and help them use the system, make it actually function. So they encompass everything, not limited to the following functions: sales, order entry, raw materials, accounting, human resources. Major ERP systems, we've actually kind of looked at this list already. I'm going to skip through it. In terms of e-business, this is where a lot of the ERP systems are being applied for the strategic advantage. And the thing about the concept of the e-business, it's running through virtual company kind of environment. It's using a lot of technology for the automation of how things are being shipped, how things are being ordered, the interface between the customer and the salespeople. So why not use an ERP system to do the whole thing? So ERP system can become the backbone of an e-business, essentially. So an e-business has to keep track of and process tremendous amounts of information. We have tons of volumes of customers, if you think about it. It has to. That's what we're making. We're not making as much as we would on a smaller business that would not service as many customers, but because we're an e-business, we're assuming millions and millions of customers, hopefully, and so our margins might be a little lower. And you have to realize that the information that they need to run the e-business, stock levels, various warehouses, parts. So think about, for example, a Barnes & Noble, great example, or an Amazon. Actually, Amazon.com would be better, I think, actually. The publishers here, publishers there. The ERP system can essentially run everything from the shopping cart to the shipping to the drop, to the ordering from the supplier, to finding out if the supplier even has the product. Streamlined instantly and driven by the customer, which makes it really nice. To do it manually would be a lot of work. In fact, a lot of e-businesses started out with a website and a shopping cart, And then, in fact, believe it or not, companies still work like this. They get a printout. They come in the morning. Somebody like ships the order. You know, it's like it seems kind of archaic these days, but people still box stuff up, put stuff in boxes. Like I like computer companies do this. A lot of people that sell stuff on eBay do this. Actually, they buy and sell products on the internet. They get a printout. They take the printout. They make a shipping label. They put it on a box. They take it over and drop it off at some shipping center, or the shipping center comes and picks it up. In a true ERP environment like an Amazon.com, they can't do that. It would be way too time consuming. Instead, they have a system that automates the whole process. So there's no physical human being in there packaging anything. In fact, in a lot of cases, the packaging can be done automatically through robotics at the publisher's location. So, which is kind of like why some of them actually look like they were packaged by robots. You know, like the book is sealed. Have you ever received those books that are shrink wrapped with the package? There was no human involved in that. It just went down this thing and it was shipped, and then the label was put on it, and the sale took 2 seconds to complete, and it was shipped out. That's the kind of way people should be doing business these days. So the major part of the online efforts of many e-businesses involved adding web access to the existing ERP system. So that's where a lot of the jobs actually are in. Building interfaces to the ERP system for e-commerce, for web applications, for self-service human resource company, self-service systems for human resource applications and stuff. So many e-businesses want the same thing for their business and their infrastructure. So rather than customizing and building something, they're doing pre-packaged ERP systems. Not too many of them on the market, but big source of some potential revenue, I think, in the future is to have a pre-packaged kit. You know, you install it. There's your business. So here's your e-business in a box, and fill it in with your supplier names and your customer, you know, and here, put it out, connect it to your website. And there you go. There's your business. In fact, there's a couple of those companies that are trying to sell, like, you know, get-rich-quick schemes in those magazines. Have you ever seen the entrepreneur magazines? Here's a turnkey business, you know, give us $10,000 and we'll send you the software kind of thing, which is an elaborate, small little ERP kind of system that's integrating everything. All they have to do is learn how to use the system. But the system, everybody else is using it. So what kind of competitive advantage are you going to get? So the cost of implementing it, extremely expensive. I don't even have to read the slide for that. In fact, expensive and time-consuming. And a lot of the costs are not with the software, it's with the business itself. The cost of doing the process reengineering is the most expensive part. So you need extensive help from consultants to configure the system. That's why you guys all take SAP classes, so that you can work as a consultant and actually work on these systems. Because there's nobody at the company that knows how to do it. So you have to pay consultants, and you have to work around existing business practices or change them. And what ends up is easier is just to change them. And so you have to put better practices in place to meet the requirements. And that's actually kind of harder than working on software. It's trying to tell a company that they need to reorganize their workforce, their business processes, because what they're doing is not going to be effective with this new system. And nobody ever wants to change their job. Nobody ever wants to deal with human resource issues or deal with people and labor and business processes. So that becomes a headache. Consultants who supervise the integration process are often referred to as systems integrators. Another word for that, systems. So sometimes systems analysts, sometimes integrators. So a lot of it's outsourced. So outsourcing the ERP system, sometimes the system isn't actually at the company site. The system itself is running on a server that's being actually, and this is the most expensive way of doing it, you've taken all of your business processes, outsourced them onto a server that you don't own, that you have to pay a monthly expense for, that you can only hire those outsourced company consultants to work on. You're locked in, and if you get out of that situation, you might as well just close your doors and start over again, because you have to. All of your stuff got transferred over to somebody else's control. You're stuck paying those people for the life of your business. Not a bad business to be in if you're the one selling the ERP system. Some businesses choose to outsource not only the installation, but also the ERP software itself. Sometimes they get custom-built software, not too hard. If you want to do it correctly, what you end up doing is figuring out what you need getting it built module by module and having it done yourself and not outsourced or not housed on another server, housed on your own server. Is there an attendance thing going around? I lost my TA to a TA meeting next door, but we should be taking an attendance. Does anyone have a piece of paper? Oh, there it is right there. Could you circulate? It dawned on me that I hadn't circulated it out yet. Could you circulate that around so you guys can get credit for being here? Thank you. All right, supply chain systems, we've looked at this already as well by definition. Let's take a look at some of the strategic advantages in terms of the IT implementation. The typical supply chain system might address planning, vendor, manufacturing, logistics, and believe it or not, customer relationship. So you're thinking supply chain. Well, what does that cover? This is where we get some gray lines between some of the different cross functions in the organization, and hopefully the more gray lines we have, and this is gray on purpose, the more, does it look gray? It does look, actually kind of looks black. The more integration and the more our supply chain management system starts running like an ERP system. And the more we can actually start calling it. We can actually translate, we can start out with a supply chain management system, turn it into an ERP system, and add on support for the other functions as well, which is how some people grow. As I mentioned before, in a best planned world, we start out small. We get a custom-built ERP system, and we start growing it to meet our needs little by little as we start changing and doing our business process re-engineering. Well, 9 times out of 10, 90% of the time, it's easier to start with supply chain management and then start building customer relationship management into it, start building logistics, some of the other things that we need to do into it, depending upon whether or not we're manufacturing a product or building a product or outsourcing something component of the product. So if we're heavy on supply chain, we start in that angle. If we're heavy on customer relationship management, we could start with that and build the ERP system from that, actually. So it depends on the focus of what's important. Here, the big arrows on the left and right are kind of the new thing where we have payments, and then we have money coming in one direction, one out the other direction. Raw materials, finished products, so we're paying for products. And we have suppliers on the top, if you can't see it, customers on the bottom, and we have the business process in the middle. So this is kind of like the assembly of the product with multiple parts from different vendors. We're receiving payment, they're receiving payments, and it's all integrated. We don't have to do any manual accounting to figure out how much they're owed. That's automatically done by the CRM, by the supply chain management system. So we can actually do some statistical analysis and reporting to see which components are highly used, which one of our suppliers is the most reliable, which one is the cheapest, how can we restructure things. And just as a side note, all of these systems are usually closed. They're usually on an intranet. They're not public systems, and you'll never run into it as a consumer. These are all business end systems. So with the internet, we can connect it to make it available through the internet, through e-businesses, but it is still housed on a back-end server. Because what you can't do is expose that. If you expose any of that, you might as well just give up and close your doors, because lack of security right there is going to cause you issues. Most importantly, also the vendors themselves are largely the same vendors as the ERP systems. In fact, the supply chain management systems, customer relationship, they're all part of a puzzle that fits together. So you buy piece by piece, and then you snap it all together, and you got an ERP system, hopefully. So then you get vendor lock-in that happens, which is why people who were with PeopleSoft, who ended up going the SAP route, end up getting stuck with the SAP route, because SAP ended up being a cheaper kind of solution than the PeopleSoft solution, and PeopleSoft was always too difficult in terms of the technology for to hire consultants, and we didn't have any consultants. And if you think about the concept, anytime something new is introduced, and even though it's been 10 years since all this stuff started, it's still new. The early adopters who pick up are the ones who end up failing, usually, sometimes. And so the second ones end up being more popular. It's like the first model of a car, you don't buy it, the first model of a product. Like the first iPhone that came out wasn't as good as the one that comes out now, kind of thing. So SAP was second in line, which makes it more popular just right there. And once you get in that route, you're stuck. You're locked in. Everything is SAP, everything. So you can't You're not gonna buy PeopleSoft related components or support. You're not gonna pay for support for something. You're gonna put it all under one roof. Long story short, the ultimate goal of the business ERP system is to complete the optimization of the internal business process. So you're buying it piece by piece, putting it together in the hopes that you're going to have a complete system one of these days, if the company makes it, which hopefully they will. So, all right, so we have two basic types of supply chain management systems, and in terms of the software, we have the planning and then we have the execution. So depending upon what we're using it for, we have different options in the purchasing of it. So using mathematical models to predict inventory levels, that's going to be more the planning. That's going to be where I said statistical analysis, because it's all statistical analysis based, because we're predicting, we're figuring out information about the data that we've housed, hopefully, and we're basing it and we're making decisions on it, like how often should we purchase something, how often, what is our turn, what are we making on this anyway as well. And then we have the execution software is used to automate the different steps in the supply chain management process. So you're automatically sending purchase orders to vendors, and when inventories reach a particular level. And we actually have vendors. In fact, now we have vendors who log in, check themselves, recheck themselves. It doesn't necessarily mean that the company shouldn't be monitoring anything. So a lot of the reports, a lot of the information that come out of these systems is cross-checking. What is our percent of error associated with how early we ordered something and ran out of the product? Are we running out of items before we're receiving them? Do we have a warehouse full of parts that we don't need that some vendor sold us? And how did that happen? Because the management of the system is the big part. The system does itself. If you actually have the execution and the automation built in, we're just people watching the computer. It's like monitoring a network, essentially. And the job is essentially to look at what's going wrong and fix the problems. And a lot of it also is, in terms of some of the consulting work, is making the reports. It's figuring out, we don't have the capability of doing this, we need to do this. We need to look at this, we need to look at that, and then figuring out what needs to be changed, what needs to be added. Players in the game, I2, and they're still around. Oracle, SAP. So it's not order of preference, it's just a couple of the different components that you may have seen, you may actually be familiar with already. So depending upon your background. Advanced planning and optimizer. This is just actually it's a very old screenshot. Easy access kind of interface. So levels of SAP and advanced planning for the organization. We have supply network design, supply chain cockpits, management cockpits that can be created, and that usually has dashboard concepts in it. In fact, the concept of the management dashboard is part of the key components of most of these ERP systems. And the dashboard is kind of like what's happening with dashboards in general and other software. Your phone is sort of like a dashboard. It has indicator lights to tell you how many messages you've missed, how many text messages you have. Your Windows 7 now has widgets that you put on your dashboard, which is your desktop, where you've got the weather, you've got information that's vital to your day-to-day life sometimes, maybe not. It might be instant messaging or something, I don't know. But long story short, you need this for the system because you got this Oracle, you got this system that has a bunch of information in it. How are you going to get it out? You're going to constantly run reports and look at it daily? No. Instead, what you're going to do is build these interfaces called dashboards to provide the level of information that's needed from the abstraction of what the manager's doing. So if the manager's trying to check on how fast the manufacturing is progressing, do we have a problem? Do I need to go out there and take a look at it? You can have like day-to-day incremental, like a graphic. And most of the dashboards are graphic, actually. They're taking the data and they're putting it into a pie chart, or they're putting it into a bar graph that's showing you how fast something is running and how close on target we are. Or maybe it's doing cost analysis, or maybe it's doing something else. And then you put all the dashboards together into what they call the management cockpit. And most of it's software-oriented. Some of it actually might be like generated on a true like cockpit environment, like with screens and stuff, So it looks like you just walked into an airplane cockpit. You got all of the different dashboards with all of the different panels of controls. And believe it or not, some of the interfaces are so sophisticated you can actually adjust. You know, you can turn up the overtime, adjust the speed of something, slow something down by a click of a button, essentially, where you're automatically reducing your expenses because you're running too fast. You're almost done with the budget, but something's going on. And normally it might also be, effective, slowing down the production to reduce the costs, speeding the production. So it depends on what you're using the cockpit for. Supply and network planning, collaborative planning, forecasting, replenishment, all kind of work into the kind of different levels. And we have down on here the alert monitor as an example, where we could send out email messages, send out alerts, warnings to say something is wrong, we're running low, we haven't reordered for some reason. Because here's what ends up happening is it's kind of like the best planned algorithm that someone puts into place. Because in fact, this is what most of the problems with ERP systems is a failure of the management staff to understand what the system's doing and properly manage it, like properly monitor what's going on. And a lot of them lack, actually let me go back to this slide, a lot of them lack the different levels. They lack the different tools that are implemented because only half of it's implemented. Or it's implemented but nobody knows how to use it. Or they don't have a dashboard, they don't have a cockpit kind of, or any type of monitoring kind of control over it, with no indicators, nothing. So they can't actually, the system's not telling them anything, so they're having to go and ask the system. And that's when people resort to all sorts of reporting. Problem is, once you print a report, it's stale. It's stale the moment it comes off the printer because the environment's changing, things are changing, and you have a static report. And you're looking at the static report trying to make decisions on a dynamic environment. It doesn't work. Which is why a lot of the tool sets these days, it's all computerized, it's all dynamic, essentially. Which is how that monitoring of the dashboard and the cockpit kind of concept work together. Because then you can really streamline everything in a real-time fashion. And it is real-time, actually. Here's our Oracle supply chain planning. Oracle, as we all know, is a huge database kind of company, but they also work with supply chain management in terms of their tool sets that work with a lot of their different products. You can actually kind of cross-develop with this. So it's part of the Oracle e-business suite, family of supply chain management solutions, and it includes demand planning, collaborative planning, inventory optimization, global ordering, stuff like that nature, and what do you call it? Generic areas of needs, most companies. And that's when you get the consultants that come in and kind of create special tools that are included and are not included in the generic pack, because not every business is the same. So some people actually might need something else, outside. You might need a specialized demand planning system or something that's different than the generic model. So, and then we have our customer relationship management. We're all familiar with that as well. And now we actually have the eCRM, which is kind of a different differentiation between the traditional versus the electronic system. eCRM uses ERP systems. They're not standalone customer relationship management systems, because everybody calls everything CRM these days. Like the shopping cart is a CRM. Technically it is, actually. Kind of, sort of. Well, not really. Doesn't really. Loosely falls in the category. A survey. I don't know. All these things that end up being generically part. But when we start talking about ERP and putting it together, then we're looking at if the customer has owned the car for more than 2 years, or their car hasn't had this recall yet, we can actually send out a friendly, here, get your free windshield wiper or whatever. Or get your free, we've recalled this, which is what they used to do. They don't actually send it out anymore. Because it ends up costing manufacturers money, to recall something. So they make it publicly noticeable, so if you're an active consumer, you can go online and check for some recalls, or while you go to the dealership, you say, hey, are there any recalls? In the old days, the company used to send you something in the mail, hey, you bought this car and we recalled your steering wheel. But why are you going to do that nowadays? Because they're going to save money by not letting you know personally. But most of the ERP systems and the collaborative eCRM is doing that. which is good because then it buys the customer into using the system. So if you want to know about recalls, then you give them all of your information, and then you become part of the system. In return, you're supposed to get better relationship with the company. So there's a reward to being involved in it. If you're not involved in it, you're never going to get the notice. So it allows e-businesses to match consumer needs with product plans and offerings as well, remind customers of service requirements, and determine what products a customer has purchased. And in fact, Google's doing a lot of that stuff actually, because companies like Salesforce.com can actually do data mining on Google information and data, as well as other, to come out with social groups, social demographics from internet data on consumer behavior. Because in the old days, people used to market towards teenagers, market towards adults, computer users. We had these traditional categories. Now everybody's kind of more diverse these days. It's hard to figure out what consumers actually want to buy. Do all college students actually fit the same mold anymore? No, And then we have, different, work at home mom. We have no work people. We have that industry. So we have to use what we can use. And so we have companies like, as an example, Salesforce.com, which is a CRM system example. And it provides a service. And it's kind of interesting where they get, and you can't see this, you can't read the screen, it's too far away for you. But what you're looking at is kind of a service of buying somebody else's information, buying leads, buying information, and creating a system that your internal salespeople are using to collaborate their sales efforts at the same time. So the software is actually providing you with data that other people, other companies, other consumers of the product is actually providing. It's kind of like a shared collaborative environment without the sharing. It's kind of like you're getting it anyway. And so a lot of people like to use a variety because these guys are only going to have a certain amount of data. You're only going to be able to use it for certain things. So you're going to use other avenues to collect other sources. And in the future, there is probably going to be, or suspected that Google's going to come out with a bunch of applications for customer relationship management, for dealing with people, for demographics, for mapping, for all sorts of different new applications with all the data that are collecting. Multi-channels, which is basically the point I'm making in terms of getting at them through different avenues and not just relying upon one source or one channel. And we used to think, oh, the e-commerce, e-business, that's just one channel. There's other channels out there. The problem is you can't rely upon just one, is the point. So the concept of data mining and web mining is pretty much the wave of the future in terms of CRM. And it creates business intelligence, which is why Google is so popular these days and why they're growing. They're a huge data mining company. So data mining is the process of using mathematical techniques to look at hidden patterns in groups of data, thereby discovering previously unknown relationships among the many different pieces of information that's stored in the database. So a lot of you guys didn't take my data mining course because you're not software engineering people, you're business people. But in the software engineering data mining course that I taught last term, we went through artificial intelligence, statistical analysis, and traditional type of data mining techniques. And to sum up that entire course and sum up the entire concept of what data mining is, you're not going out and asking a database to tell you what your best-selling product is. Instead, you're going out and saying, what do you want? What can we give you that you're going to buy from us? And the data is coming back and telling us, we want MP3 players, or we want this, or we want that. So we don't know what we want. We're not asking for something. Instead, we're mining the data to let the data tell us what it has to offer. And so if we kind of reverse the concept a little bit, then we're not guessing. So a lot of people are saying, what are our year-to-date sales? Because when you do a query, when you do a regular old database kind of analysis, you know what you're looking for. When you do data mining, you're looking for patterns in the data to discover untapped markets, trends, information that you don't already know, that you don't know what you're looking for. So you can do some data mining and find out that all of our customers are coming from the state of Kansas or something. Or do some data mining going, we're really in the wrong business. Or we need to sell this product. They don't like our product. They like this one over here. or something related to something that's going to help your business. And what it does is it gives you that concept of business intelligence, what you need in order to actually be successful if you want to be competitive. A data warehouse is a database that contains huge amounts of data, such as consumers and sales data. Data warehousing should not be confused with data mining or web mining. Web mining is data mining done on the internet. So those two are actually kind of the same concept. Data mining looks at clustering, groups, patterns, trends. It's like doing stock market stuff. Something's tanking or something's going up. And it works with demographics, and it helps us analyze the information. Data warehousing is information we already know that we're putting together for different applications. It's taking internal and external data that might be used to help us solve a business problem and putting it together all under one roof, calling it a warehouse. And then we have tools that work with the warehouse that tell us what, in fact, a common warehouse kind of environment would be something that takes demographics for census data. So, so you can figure out annual household incomes, number of children in the house, stuff like that. And cross-check that with maybe, how many stores are in the area, using maybe some business data associated with the demographics of the regional area. Cross-check it with how many colleges, what the trends are with, are there increases in the college applications, or are people dropping out, blah, 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 number of graduates. Cross that with, some recent event, like an earthquake or flood or something like that. Cross that with, and you're basically crossing all this information to come out and say, we need to sell blankets or something, or, we need to sell something, or, coming out with some intelligence from it. So what do we got here? We got the whole thing out now. Is there one more? Nope, there isn't. There we go. So what does data mining do? Explores your data, finds patterns, performs predictions, hopefully. That S belongs at the end of predictions. And the tools that we're using, querying and reporting analysis, say what. Data mining says how and why. So it answers questions about how and why instead of the what. So, because a lot of people, the first thing they say, oh, we don't need to do any data mining. We have reporting. We know how to query the database. We have all of this data. The problem is you can't do that. Because if you do that, you only know what the data is telling you. If you actually have to implement data mining these days as a company in order to really see how things are changing and what the effect of something actually is. And then also predicting the future. It's like, not to sound like gloom and doom or anything, but you actually have to use business intelligence in order to get anywhere. Otherwise, you can't compete. Oops, here we go. There we go. The slide's kind of funny. Okay, so here's an example of the SQL Server 2005 Business Intelligence, where we're taking and integrating, analyzing, and reporting. And this is basically the old-fashioned way of doing something. Nowadays, it would be done in real time using a dashboard on the management cockpit of some sort. But the same concept applies. So we have to, in order to do anything, we have to actually acquire the data. Most companies do that. Most companies save everything. And then they fail on the analysis. Some people do partial analysis on the data. They go, okay, well, we can do some data enrichment, maybe. And we can actually apply some logic to it, analyze the data, see what we have. And then even fewer companies actually do the reporting on it. Figure out, what distribution do we have? How many of our students are A students, B students, or C students? Actually, we're all A students, I think. So, data access, basically for the masses in terms of the reporting. And the reporting people don't know what they want to report on. So we can sort of see how the intelligence grows in that kind of direction. And so the more we apply to integrating, analyzing, reporting, the further we get to the reporting side of things, the more information we're getting out of it. And the information we're getting out of it is giving us that business intelligence that we're looking for. And here we have algorithms. And this is why people who work in this area major in either statistics, artificial intelligence, software engineering. Because what ends up happening is they can't just study information technology. That's not going to give them anything. And information systems is going to tell them how to work with the systems. But the hardcore technology is in the algorithms, coming out with the decision trees, clustering, And these, I'm not going to go through each one of these things, but they cross over into a lot of different fields. Now we're using a lot of neural networks, actually. And you're probably going to say, oh, it looks like Greek. What are we going to use this for? Almost every single credit card reporting company uses this right here, neural networks, where it takes and crosses and implements unnatural mutation to predict how creditworthy you are, and it gives you a score. So somebody has to come out with that, right? So we have different companies because they're using different algorithms to do it. The algorithm itself might be implemented in the form of a neural network. It might be a clustering technique, might be a sequence clustering, an association. And this is pretty much the basis of data mining. And these are the things that are implemented in terms of the information systems technology tools that are applied for data mining. As an example, on the decision trees, shopping cart applications use this. Purchasing engines use this. This is more of the manual. Actually, when I think of decision trees, I always think about those old. You call in for support. It says press 1 for this, press 2 for that, and it says press 1 again, press 2 again. All you're doing is making a bunch of decisions, yes or no answers. Well, you can do that without annoying the customer. For other applications, that was like the application of a decision tree to technical support and customer service was a bad idea. But you can apply it to other things, like should this person qualify for the loan? Well, do they make a certain amount? Yes. Okay, good. Do they have a car payment? Yes. Oh, okay, no, maybe not. Do they also have this? Yep. And then they follow through until the end of the flow chart where they end up with give them a loan or don't give them a loan in terms of making a decision. So a lot of business knowledge, business logic can be transformed into decision trees to allow essentially, some sort of automation in terms of the CRM system or the ERP system. And clustering looks at, basically instead of asking for where our customer's coming from, it's going to show us where they're coming from. And we're going to see how big each one of the region sections are. It's kind of like that Verizon network. They show you all a little red, but the whole map is red. You're familiar with that little red things. And the guy's sitting in the restaurant and something happens and all the red stuff falls down on him. So, the Verizon network. So, and it's a clustering. It's a clustering technique. Time series, we're all familiar with this actually. This is a traditional Excel kind of approach to business analysis where people create a graph. And they say, trends are, where sales are down, or sales are up, or, we're not making any money. Sequence clustering takes and actually crosses clustering with decision trees to tell us if we make it to this area, how many of these people fall into this category, And what ends up happening in sequence clustering is the market big enough for us? If we sold every person, and there's only 5 people in the world that would, after we did our sequence clustering, we came out with 5 people who live in the state of New York who would buy our product. Are we going to make enough money off of those 5 people? Probably not. It's only 5 sales that we can possibly do in our entire business career. But we don't know that until we cluster it out and then follow through a sequence to make decisions on which is our final cluster and which direction are we going in. People decide what products they're going to introduce, what products they're going to discontinue by using sequence clustering in terms of the analysis. And the association, this is Google. This is what Google's doing. It's taking your contact lists from your emails. It's taking your Google Voice conversations and your text messaging. Everything is saved as a data. And the data is being associated, it's being clustered, and associations are being created so that you can figure out, or companies can figure out, what demographic you fit into versus, given your associations. So this person, Bob, in the state of California, knows a lot of people in New Jersey. Okay. And the average age of everyone he emails is under 30. Okay. And he seems to correspond a lot with schools and universities. Okay. So then they can pick point and say, well, this guy, he might be a good candidate for an MBA program or something. He's young enough, he still wants to go to school. And it's going to be located in New Jersey. So, that's perfect. He can move to New Jersey. So it's kind of like different ways of finding associations that people are creating through the trail that they're leaving on the internet, and using that with GPS applications, statistical analysis applications, purchasing engines, all sorts of different applications to utilize that data. TA meeting's over?
Yeah.
Wow, we're almost over. So. All right. Bayes networks, artificial intelligence, traditional approach to sorting and sorting, and then neural networks that tries to take human learning, human algorithms from an artificial intelligence point of view, provides analysis on those to kind of see connections and how things are transforming. It's kind of like putting something through a filter and seeing what comes out at the end, and you're just getting what's out at the end. So you're filtering information with a Bayes network, essentially, which is why the credit reporting companies do that. They filter out all the bad stuff, and they see how much good stuff's left over, and they put a score on it. They say, you have 600 good stuff. You have 700 good stuff. You have whatever, so it's always a positive. It's whatever you have left over after they pull off all the bad stuff. So, plus linear and logic regression. Well, I'm not going to talk about regression, but yeah. So the relationship among supply chain management, ERP, and CRM, well, they're all together. And this is the point I was trying to make when I was talking about ERP. It's a broader level of supply chain management that might actually encompass customer relationship management and might be part of the center here of the ERP system. So that's why we can kind of build it in pieces and put it all together, which is what a lot of companies do in the end. So. All right, I think it's probably a good stopping point now. Are we done? Or do we want more? Was this no or yes? No more. We're done for today because I think our time is kind of close. All right, thank you. We'll end it because this is a good stopping point because then I can talk about a little bit more and give you a lot more details on SAP because you might be interested in taking some SAP classes that we offer if you haven't taken them already. But we'll save SAP for next time. Make it interesting so you'll come back. So, all right, thank you. Make sure to sign the roster if you haven't already.